All right. Hello, everybody. Let's look at question C, which is asking us to find the answer to the households problem. And we're going to need to know pi star because the household knows pi star because of rational expectations. So let's begin from the beginning, though. Let's start with the household choice. The household's utility function, we recall that the household's utility function is minus 1/2 the difference between their guess of pi and the bank's pi, which the household knows is pi star. And this maximization will imply that E of pi is equal to pi star. Okay, so this logic is all still true after we max UHH. We max UHH with respect to expected pi, and we'll get this from our FOC. So this is our first order condition. And before we were done here, well, we weren't done, but we're going to plug in pi star. So we plug in pi star, which is right here. And that's what we solved for in the last video. But we have more work to do now because this is a function of expected pi, as we noted. So we have to dig that out and combine and get it down to just one small equation. Okay, so let's distribute the, let's split this. We're going to split by distribution out the A expected pi. So it's going to be A squared lambda over 1 plus A squared lambda expected pi plus A lambda over 1 plus A squared lambda. And then what's left from the split is just K minus YN minus epsilon. And that's E expected pi. So let's take this over to the left. And this has a 1 here, so we can factor. We can factor out, we'll have 1 minus A squared lambda over 1 plus A squared lambda. Expected pi equals A lambda over 1 plus A squared lambda K minus YN minus epsilon. And then whenever you see like a 1 minus something, 1 minus a fraction like this, it's nice to always try to see if it helps to write 1 as the denominator of the denominator. So I'll rewrite this as 1 plus A squared lambda over 1 plus A squared lambda, denominator over the denominator, minus A squared lambda over 1 plus A squared lambda. And we can combine these now because they have a common base. And the A squared lambdas are going to cancel, right? We're going to end up with just 1 over 1 plus A squared lambda. Okay, I'll do like this so I can keep writing. Equals A lambda over 1 plus A squared lambda K minus YN minus epsilon. Bring it over, and so this is going to cancel with this, and we're going to get the expectation of pi is equal to A lambda K minus YN minus epsilon. But this is an expectation, so this should be an expectation as well. So we need to take expectations of the right-hand side because expectations can't be random. That doesn't make sense. And this is random because we have this epsilon here, right? So the expectation of pi with one too many feet of pi is going to be the expectation of A lambda times K minus YN minus epsilon. And expectations are linear, so we can just distribute it over everything. So we get the expectation of A lambda K minus the expectation of A lambda YN minus the expectation of A lambda epsilon. And the expectation of deterministic things is themselves. So A lambda K is all deterministic, and we know what to expect. A lambda YN is also deterministic, so let's actually just bring this back together. We'll get K minus YN. And because it's linear, we can we can pull out terms that are unrelated to the expectation. So we can just get it down to this. Multiplicative terms. We can take them out of the expectation, provided that they're not random. And we remember that epsilon is distributed normally 0 sigma epsilon. So the expectation of epsilon is mu, which is 0. Right? Because this is the mean. Cool. So this is 0. That goes away. And our answer is the expectation of pi at the optimum is a lambda k minus yn. Does this make sense? Good question. A lambda is the original answer, right? So it's always nice when you can see the simple answer inside of the more complicated model. And we add this k minus yn. So does it make sense? If the target of the central bank is equal to the natural rate of inflation, then the households will expect no inflation. Sorry, the natural rate of growth. Then the households will expect no inflation. I think that's true. On the other hand, if the target is above the natural rate of inflation, so the households now expect that the central bank is going to use its policy instrument to increase growth, then they will expect there to be positive inflation, which is exactly what increases growth. So that makes sense. And vice versa, if the target is below the natural rate of inflation, that is, the central bank wants to cool off the economy relative to the natural rate of growth, then they will reduce inflation. And that's what the household expects. So that makes sense. So I'm quite happy with that. And so in the next part, we'll do part D, and we will put everything together and find the social welfare. So I'll see you there.